Dear students, we continue with the lecture. See, we were talking about heap insertion, right? So we first examined that now 6, we found a proper place to insert the element 6. Then we examined its root parent node, and we found that 6 is having less value than this parent node. Hence we here swapped. Hence we swapped the values, right? Now checking out again the new position for this element 6, and then check its parent node value. We found that parent node is again having value greater than this child node. Again we need to heapify here, so here we will be swapping it again. As you can see in this figure, we swapped out the values, right? And now it satisfies the heap property. So then terminate and heap when we have reached. So this checking of the parent node is always done, and we continue to do this. We continue to heapify the values until the root node is reached and the child is greater than the parent node. The child node is greater than the parent node. Then we will stop this process. Okay. So see, we again checked out this value to its parent. Now it satisfies all of the properties of heap. Hence now we have balanced the values to maintain min heap property. I hope you are following me. Now let us have a look at when you want to remove an element from a heap. So that is called as heap removal. That will remove an element. So actually we are removing an element from priority queue and using remove min method. So it will remove the minimum or the smallest value from the queues here. So the smallest value is obviously at the root node in case of heap. So this third element will be removed, right? After removing this element, the three values will result in unbalanced tree. Okay. So then again beginning with the down heap, we will begin with the down heap here. We will start with the child nodes, right? And we will simply replace the root node with the child node. Okay. So here in this case we replaced the value 20, where it was to the right of this child node 7. It was the right child of this node. Further we don't have any element, so we will begin with this element. Remember what we are doing here. We are simply traversing from in this direction, right? Since 8 is not having any child, so at this level this is the node where it is having left child and right child. So we'll begin with the right child. Simply replace the root node value with this right child value. Okay, so we replaced it. Then we will do heapify, or we will perform unheap operation. We will check out the child nodes, right? We found that the left child is less than, so we replaced this 20 with this 4, right? Then further checking again, the values will be swapped out to satisfy the heap property, and the resultant structure will give you a heap structure. Then further doing this will result in this structure. Till it is done, then we will stop this process. So when to terminate this mechanism? In a situation where you have reached the leaf node and when the child is greater than the parent node. Then you have to stop doing this. The final heap structure that we are getting in this case is as shown here. I hope you are able to understand this. Now let us see bottom-up heap construction. When we want to construct a heap in bottom-up fashion, that means we are constructing a heap right from the leaf node towards the root node. So this is bottom-up traversing. We construct a heap sorting n given elements. We are assuming that there are n elements that are given to us. Using these n elements, we try to construct a heap in a bottom-up construction with n log n phases. That means the time it will be requiring to construct a heap is log n. It will require log n phases. So in phase I, pair of heap with 2i minus 1 keys are merged into heap with this key. See, 2i minus 1. So 2i minus 1 will be merged into a single node here. Right? So since we are traversing from the leaf node, we try to merge these two to the upper level. Right? We find an element that can be merged with it. Okay? And this is how we process. So we are given two heap here. See, in this case, if we are trying to merge two heaps, this is one heap, this is another heap. Now if we try to club them into one, then we create a new heap with root node sorting k and with two heaps as subtrees. So we try to create a new heap with k elements and we try to merge them. So see, these 2 and 3, this will be merged into a new element having a new parent here. So 7 is the parent again. Then we perform heap down to restore the heap order property. Then we check out whether this is satisfying the heap property. If not, then we will perform heapify operation or unheap operation right from the downward direction. Okay. Now here we have an example to better understand. The example given here includes 16, 15, 4, 12 and so on. These are the values to be inserted. So see how we begin with the values right from the rightmost value and the rightmost child. We write all of the values here. Okay. So 20, then after that 23, then comes 9, then comes 6, then comes 12, 4, 15 and 16. Okay. Then we have next upper level to be inserted as 25, 5, 11 and 27. Let us see how this can be done. So simply what we are doing, the two nodes we are connecting it with a parent node as 27. Then these two nodes are connected with the parent node as 11 and further these two as having parent as 5. Then 15 and 16 having parent as 25 at the next upper level. Then we have here down heap operation. Okay. So down heap will check the values of the parent node and their child nodes. If it violates the property of heap, then it will perform unheap operation to balance the values. Okay. So see here, now 25 is greater than 15, hence swapping will take place. So this is how the values will be swapped out. Looking at this, now 5 is again greater than this 4, so these values will be swapped out. Here 11 is greater than 6, again interchange of values will take place and so on. Okay. Now we need to insert the next upper level, that is 7 and 8. So we'll again begin with the right child and insert the values and connect them with, so these two will be the child node, this will be the parent node. Hence we have taken the heap to the upper one level up again, and then again we need to do heap down operation to see whether it satisfies the heap property. If not, Then again we have to swap the values. Then we insert element 10 to the heap, and again we check out whether it satisfies the values. Right from the left child, we'll first check out the left child, then we'll go to the right child. Okay, so we first checked out from the left child, right? We found that 10 is greater, so 10 will take place here. Then again 10 is greater than 5, so hence 5 is also replaced by 10. Then we found that 7 is less than 10, so hence this swapping takes place. Okay, and now it has resulted in a heap structure. So this is how we traverse. Now again we have an example. Looking at this example, how we have constructed a bottom up heap. See the values we need to proceed here: 14, 8, 9, given the values. Okay, then once this level is filled, then we go to the upper level, filling up the values. Then we go to the next upper level, filling up the values till the end. Okay, and then we examine whether they are now whether they satisfy the heap property. See here we observe that what is the value of the parent node and their child node. It satisfies. Here again it satisfies. This is also balanced. This is also balanced. Going to the next upper level, we saw that okay, this is resulting in a balanced subtree. Again here it is also obeying the law of heap. Now we finally checked out that the root parent node is not having value less than the child nodes. So here you need to heapify. How we will do heapifying? We'll check out to the left subchild, right, and then to the right subchild. Since how we checked here, see, okay, this is satisfying, but then this and this is unbalanced, right? So we'll have to swap the values. So 16 will come here, 4 will go here. Then again this is unbalancing the tree, so 16 will be replaced with 7, right? And then again 16 will be replaced with 9. Hence the final structure is this. See, here we have 4, we have 7, 9, and then 16. Okay, I hope you have understood this point. Now here we have heap implementation. So always we have to be very careful while constructing a heap. The parent should always be less than the child node. Now we have to apply certain rules. See, whatever is the value at parent node, let us consider it as k. The left children should be 2k, and the right children should right child should be 2k plus 1. So this property should not be violated. At parent the value is k, at left child the value is 2k, right? At parent the value is k. If we are taking any value for k, its left child will always be 2k, okay, and its right child should always be 2k plus 1. See here, this is an efficient property. We have to be very careful while implementing it. It is efficient because unless we do this, it will not result in heap structure. Okay, so this is the first node, its left subchild and right subchild. So this property should not be violated, and we have to proceed in this fashion only. Now here we have the code to implement heap insertion. Okay, an algorithm is given here, and it takes log 2n computation. Then we have a module called as delete heap for deleting an element from the heap. Now there's the next point, that is heap sorting. So building a heap is the main thing here. Then remove min heap is used, and heap sort we will study in the next lecture. Till then, take care. See you in the next lecture.